Okay, so this problem asks us to do some diagram tracing. It says, given the commutative diagram with exact rows, meaning that for each map here, and these are all R module homomorphisms, in the rows, the um, image of each map is the same as the kernel of the subsequent map. And so we have these two short exact sequences in the rows, and then we have maps from the first row to the second row. And the problem says that if the first and third downward maps are isomorphisms, then so is the middle one. So this is called the short five lemma. And here we are working with R module homomorphisms and R modules. So the way we're going to do this is we're going to show that if H prime and H double prime are surjective, then H is also surjective. And then for the other part, to show H is injective, we'll use the fact that if H prime and H double prime are injective, then it follows just from that that H must be injective. And then once we have that H is injective and surjective, then H is an isomorphism. Um, However, to keep this somewhat shorter, we're just going to do surjectivity. Um, Also because injectivity is done directly in Dummett and Foote. Okay, so let's prove that H is surjective, and what we're going to need is that H prime and H double prime are surjective, which we have because we're actually we have that they're isomorphisms, but we're going to use that they're surjective. Okay, so um, let's start with an element. So let B be an element of M2. And let's um, um, consider, well, there's really only one thing that we can do, keeping this picture in mind. If B is in M2, the only thing we can do really is push it forward. So let's consider G2 of B. Well, now since H double prime is surjective, there exists some A in uh, M1 double prime such that H double prime of A is equal to G2 of B. And now, since the top row is a short exact sequence, that means that G1, right, its image has to be the kernel of the next map, which is the zero map. So its image has to be everything. So it's in particular surjective, right? So since G1 is surjective, there exists some element, let's call it C, in M1 such that G1 of C is equal to A. So then what do we have? So then H double prime composed with G1 applied to C gives us G2 of B. But remember, this is a commutative diagram, so by the commutativity of the diagram, which is one of our hypotheses, right? This map H2 composed with G1 has to be the same as G2 composed with H. H2 composed with G1 has to be the same as G2 composed with H. In other words, if we go this way, that's the same as going that way. So H2 composed with G1. So this means that G2 composed with H of C is equal to G2 of B, or so just to be clear here, we have G2 of H of C, which is equal to G2 of B. Okay, and now since G2 is an R module homomorphism, uh, in particular, it's additive. So what do we have? We have G2 of H of C minus B. Um, that must be equal to G2 of H of C minus G2 of B, which is 0 because these are equal. Um, so what does that mean? It means that H of C minus B, this element, is an element of the kernel of G2, which is equal, since this is a short exact sequence, to the image of F2. Kernel of G2 is the same as the image of F2. Okay, so if H of C minus B is in the image of F2, then there exists some element, let's call it W in M2 prime, such that F2 of W is equal to H of C minus B. All right. And now we also are assuming, since H prime is surjective, right? So W is living in M2 prime, H prime is surjective, so we can get something in M1 prime map of W. Let's call that um, Z in M1 prime, such that H prime of Z is equal to W. So all in all, what do we have? We have that F2 of H prime of Z. Well, H prime of Z is W, and F2 of W is H of C minus B. Um, okay, and then we're going to appeal to the commutativity of the boundary one more time. So we have F2 of H1 of Z being something, F2 of H1. Well, okay, F2 composed with H1 is the same as H composed with F1, right? Going this way is the same as going this way. So by commutativity, H of F1 of Z is also equal to H of C minus B. So what does that mean? Well, if we do some uh, algebra here, then that means that B is equal to um, H of C minus H of F1 of Z, which is equal to, since H is an R modular morphism, H of C minus F1 of Z. So in particular, we have our element, namely C minus F1 of Z, that H maps to B. So since B was an arbitrary element of M2, and we have an element of M1 that H maps it um, to it, um, we get that H is surjective. And as said earlier, injectivity is a very similar diagram chase, and the details are spelled out in dominant info.